I'm Roger Gonzalez, and I'm the chair and professor in the Department of Engineering, Education, and Leadership. I'm the director of the new ELEAD program here on campus, and I'm also the CEO of LIMS International.
I am Raymond Rumpf. I am an associate professor in electrical and computer engineering.
My name is Rosa Amelia Maldonado. I am associate professor at the biology department.
Hello, I'm Tom Davis. I am a professor in civil engineering at Utep, and I am the director for the Center for Inland Desalination Systems at Utep.
My name is Dr. Russell Robert Tianelli. I'm professor of chemistry and I'm director of the Materials Research and Technology Institute. Mr. T.
My name is Deidre Hodges, and I am an assistant professor in the Department of Electrical and Computer Engineering at Utep.
Hello, my name is Yvonne Santiago, and I'm a clinical professor in the Department of Civil Engineering here at UTEP.
Yeah, my name is David Zubia. I'm a professor in electrical and computer engineering. I'm the director of a lab, which is the Nanomaterials Integration Lab, which one of the main facilities that we have is a nanofabrication facility where we do both teaching and research, and we produce microelectronic devices.
So my background is I grew up here in El Paso. I went to Austin High School, so grew up in the center of town. Really was a pretty bad high school student, and I came to UTEP because UTEP, has an open enrollment policy, and I ended up doing well in engineering. And so from that background in engineering, I went on to work for General Electric, and I pursued a graduate degree. When I look at innovation and entrepreneurship, I see that it's really two different tasks. One is innovation is about looking at developing a product or a service in a unique way to do something that hasn't been done before. When I think of entrepreneurship, I think of how do you take that product or service and then make it something that is attractive to business, to be able to create a market for it. 10 years ago, what ignited my spark to do this was noticing that there wasn't technologies for the poorest of the poor that was affordable. They had technologies that were poorly developed, or the technologies that existed were too expensive for them to acquire. So I tried to narrow that gap and introduce products that they would be interested in. And that led to me working with students at an institution that I was at, and then innovating with them to try to come up with a product that would be attractive to the market.
I grew up in Pennsylvania. I lived in Florida for 17 years, Virginia for 5, and now I've been here in El Paso for 5 years. Innovation and entrepreneurship to me is a little bit different in academia than it is in industry. I think industry is very focused on what ideas do you have, can we get into a product next week? In academia, it's a little bit more interesting, and we're able to take higher risk technologies, work on it over a longer period of time, and move what I think are truly revolutionary technologies into industry. And that's much more difficult to do if you're stuck in industry the whole time. We have a bunch of things in the pipeline. The one that's the frontmost, we've developed a technology where we can take electromagnetic components that are in very close proximity, like the crammed environment inside a cell phone, and we can electromagnetically decouple these things so they can be really close, yet the signals are very clean, and that lets the antennas operate more efficiently. That saves battery power, lets us have faster internet, lets us put more features into the cell phone without destroying its behavior and performance.
My name is Utep Bustamante. I'm currently in the PhD program for electrical engineering. I work at the EM lab under Dr. Rumpf. I was born here in El Paso, Texas, but I was raised in Ciudad Juárez, Chihuahua, Mexico. I was raised in Juárez until I was about 9 years old. Then my family and we moved here to El Paso. I graduated here from Utep with a bachelor's in electrical and computer engineering. A couple of students from the EM lab, we started the spin-off company with Dr. Rumpf. Where we started working on the business side of the company. We also do research with him, myself and the other students that are involved in the spin-off company. Something that excites me is that I am working on revolutionary technology. I know that we will be changing the world with the type of technology we are developing here at the EM lab.
My name is Ubaldo Robles. I am a research associate. I'm a PhD candidate too. I have one more year to finish my PhD. I was born and raised in Ciudad Juarez, across the border from El Paso, and I came to Utep to pursue a bachelor's in electrical engineering as soon as I could, and ever since I've been here. What inspires me the most is the fact that we are taking on the science that we know in the world, and then we're taking it to the next level. That is really inspiring because we get to push the boundaries of knowledge, and then we get to create new opportunities for people to explore this new field.
Innovation is anything that you have and you can improve it, and then you make all the possible to get it to the market. Another interest that I have now is just to pay back to my community. And one way to do that is to lay a background of what is going on with Chagas disease in El Paso, since really is wide open because there are no really deep studies on that. So I start this work in the field station from the biology department in Indio Grande, and we collected kissing bugs. These are insects that are able to transmit the disease, and we found that 61% of them were infected. That means the chances for someone to get infected on that region is very high. Currently, I am started doing a similar study here in El Paso, trying to collect kissing bugs here in the city. We already obtained blood from dogs, stray dogs and cats, and we found that quite a big percentage of these animals are positive for this infection. That means that the insects should be positive too. So my goal is just to get a whole picture, animal, insect, human. And that is something that is on the go right now. Permits, doing this, doing that, doing everything that we can, and try to get a picture of what is going on here in El Paso regarding this disease.
My name is Brian Garjela, and I am the core coordinator for the Biomolecular Analysis Core Facility. For example, right now we're working with microbiotas, which is really new in the field. It's very nice, and it's cool that you can apply it to actual diseases and see if possible cures for the future.
Generally, I get ideas by seeing problems that exist. My first thing that I do when I have an idea is to write it down. I know I will never have that exact same thought pattern in the future, so when an idea comes to me, I'll sit down at the computer and write it up, and then I examine it to find out whether I can find any flaws in the concept, and if it still looks good after a few weeks of re-examination, then I will write an invention disclosure and disclose it to Utep, and then we will follow through and find out if it is indeed something that has patent potential. Current innovation is a sensor that measures and determines when a water softener needs to be regenerated. This sensor checks the water that's coming out of a water softener, and whenever calcium starts coming through with the product water, the sensor sends a signal to the softener and triggers a regeneration process.
One of the things that I started here with students and so on was Mayan pigments. And Mayan pigments was really, again, basic understanding of an ancient technology that when you went down there to the Mayan pyramids, which was one of the things that attracted me from Exxon to here, you wonder how they did it. And we figured out how they did it. We have a series of colors and we're selling. To the people that want to know what the colors mean, we say we have an infinite color space. What that means is I can give you a color nobody else had.
I come from New Orleans, Louisiana, and I come from a big family, 3 brothers and 2 sisters. I grew up spending a lot of time with my brothers and my father and hanging out with them and watching them fix things and do things around the house. So that motivated me to want to fix things and do things and, get into the beginning of my engineering aspirations. Innovation and entrepreneurship for me is developing some product that benefits people. And in particular, the research that I'm doing is in thin film solar cells. So it really is my desire to make a low-cost solar cell, one that's very efficient and one that can be used by people and where they can put panels on their homes and generate power using solar and cut the cost of their electric bills. And I really would like to make an impact, in the industry with these low cost and efficient solar cells on flexible substrates, portable power, something where people can bring with them, wear with them, but very affordable. In nanotechnology, we're making solar cells. It's a p-n junction diode, and it's on a very small scale when we're making these devices in the lab. The research solar cells are on a nanoscale, and so we work in a clean room to make the materials just similar to what Intel would do to make integrated circuits. So we're using equipment like physical vapor deposition to sputter the materials to make the device, and we need very clean environment. A dust particle could short circuit the device, for example. So we make small devices on a nanoscale. We use a lot of equipment in clean rooms to fabricate these devices. We use some advanced equipment to measure or characterize these devices to see how well we made the devices. We use optical electronics, UV-VIS, wonderful, exciting devices that students get a chance to work with. Scanning electron microscopes. For example, if we look at one strand of your hair right now, on average is about 80 to 100 microns, micrometers thick. Our device is 3 to 5 microns thick, way thinner than one strand of your hair. And looking at one strand of your hair with your eye, it looks totally different if you look at it under a scanning electron microscope on a nanoscale level. If you see it, it looks so different. You wouldn't recognize that as the same strand of your hair. So the same with our devices, and looking at it with our naked eye compared to looking at it under an electron microscope, what we see, it's totally different, but these are tools that we need. We shoot x-rays at our material to verify what we're synthesizing. So we're using some nice energetic tools on a nanoscale technology level to help us understand and characterize how well we're making these devices.
Innovation and entrepreneurship are 2 different things, but they're interconnected. In other words, you cannot separate innovation from entrepreneurship. When we talk about innovation, we talk about new ideas, new methods, new product that we bring into the market. Whenever we talk about entrepreneurship, an entrepreneurial person is an agent of change. And this agent of change, what it does, it fulfills a need in this market, and it, not necessarily to make money, but we're talking social entrepreneurship, business entrepreneurship, educational entrepreneurship. All of those are important for society, and what we want to do is to bring a change in society. And if that results in a bigger economy, even better. But the purpose of my entrepreneurship activities is to fulfill needs in society in terms of health and quality of life. What drives my innovation activities is when I read about something that is being used in other applications, I always question, I wonder if that could be used for treating water. And so, like the case of aerogels, they're used as conductors, and it's like they have some properties that maybe we can use for water. So then we go to the lab and just test it. I mean, it's an iteration all the time. So we have an idea, test it in a lab, and see if it'll work or not. We're using zeolites to control algae growth because, well, copper is good to remove algae, but what if we mix the copper with the zeolite, and will it still work? And so I'm in constant communication with people from other fields, and we talk about different ideas and then just test them in the lab. But really my guiding light is, what can I do to improve the quality of life of people, and specifically in water, because water is life, and we only have a finite amount of water in the world. I mean, what we have is what we have. We're not creating new water sources, so we need to find ways to, first of all, the water that we have, how can we remove the contaminants? And of course, prevention is the best method, but we cannot always prevent it. So we remove the contaminants from water. We'll have to reuse water, recycle water, so anything in that direction is what I'm interested in. Innovation activities are very different. One of them is the use of zeolites to remove contaminants from water. Zeolites are a natural mineral, and what we do is modify the surface of the zeolite to improve the absorption of different types of contaminants. We focused our research here at Utep on the removal of inorganic contaminants such as heavy metals, and we are studying and exploring different ways and different tailoring agents to modify the surface in a cost-effective way. And what we want is to make this technology available not just to industries, but also to the general public, individuals who have a need to remove one specific contaminant such as arsenic, which is here in the Southwest we have a lot of arsenic in our groundwater. It's naturally occurring. We've heard stories about Michigan, Flint, Michigan with lead, so that the residents would only need to remove one specific contaminant without having to spend a lot of money and bigger systems that are not as easy to operate, that require high maintenance, and that they're not as cost effective. Another one of the activities is development of sensors to detect heavy metals in water, and it's mostly optical sensors what we're doing. And of course, in the process of our research, we're also exploring different ways of introducing the zeolite in a way that's more efficient, like exploring the use of aerogels and nano-size zeolites and different things. So we're always coming up with different ideas, and of course, whenever we're talking about innovation, it's not a silo. We need to be interdisciplinary. So I've worked with people from geology, from chemistry, from material science, and of course the entrepreneurship portion. We need to deal with business people. We have to look for mentors that will help us do customer discovery, for example, because we want to develop technology. We want to be innovative, but also we want to make sure that what we're doing is fulfilling a pain or solving a pain in a marketing sector. Because we don't want to just develop nice technology that nobody uses. So we're also in contact with people from the College of Business and other mentors outside in the industry. So it's a very exciting field.
Actually, I grew up in this region, and I got my bachelor's and master's of science. Master of Science in Electrical Engineering here at Utep. And then I went away to get my PhD, and I worked away for about 9 years before coming back to the university. And so for me, I think it was kind of coming back home, but with a vision to really have an impact, not just at the university, but in the region, in a way of teaching students, developing their talent, and also impacting the economy locally. And so to create high technology jobs. So that's really my background. When I came here, I had a vision to really expand in the area of semiconductors and electronic devices. So we've done that with the construction of a nanofabrication lab, and so we are now at a level we've developed our technology to the point where we can be world leaders in different areas, and also try to create new companies, if you will, that would be here in the region to create more jobs for people in the city. And they're actually quite diverse, but one of the ones that we developed here at the university is to create a new way to make one of the layers that are used in solar cells. And what's novel and innovative about our patent is that the process that we're using reduces the amount of materials that are needed by about 10%, or down to 10% of what's normally used. And the other thing that's very innovative is that we're the first ones in the world to figure out how to monitor the process while the layers are being deposited. And so that gives the process a lot more control if you can monitor it. When we're doing the research, sometimes we discover things that we don't expect or anticipate. We pursue those things that we discover, and then we relate it to the need in the marketplace. And so we see that there's a need. That's how we get our ideas for the patents.
Someone find a mentor and hang with that mentor and learn from that mentor. Listen to that mentor, and then the sky is the limit. It really is.
Develop yourself. Go out if you need to go out and get an education elsewhere, but then come back, and help to develop this region.
Just to the students is follow your dreams. The sky is the limit. Not even the sky. You are your limit. So go ahead, question, try to put your ideas in a rational context. Is this not so rational? So think about. Sometimes the rational things also work a bit, but not too crazy. So, but just be constant. Go and work, that something will come.
Never give up on your ideas and lean in. Communicate your ideas. Talk to people. You don't have to have all the answers. And I think as females, we tend to want to have a perfect answer before we speak up, and don't be afraid to speak up and brainstorm ideas with others, not just other females but other men. Diversity really is what drives innovation. And
I will advise other students to keep their juices flowing. Like, don't stop if they run into some problems. Don't stop if they don't know all the answers, but keep their imagination flowing so they can achieve new stuff.
I would say first try to develop new knowledge, new research, get involved with your professors, get involved in your research, and get new knowledge. And after that, try to apply the knowledge to a problem that persists in society.
I would say that to work hard, obviously, the cliche. And it's not difficult. It's just you have to put a lot of time and effort and work into it. Anyone can do science. It's just a matter of how much time and effort you put into it.
Stay in school and eat your vegetables.